Cool. All right, let's begin. Hey everyone, I'm Tony Ongueras. Thanks a lot for being here, and thank you to the Austin Forum for the invite to come. Uh, it's my pleasure to catch all of you up on what's been going on in software development. The past 8 months have been pretty crazy. We've had a huge shift in software engineering, going from just having AI auto completing to all of a sudden vibe coding with agents. And now we're getting more into this phase where we can actually build sophisticated systems with agents. I don't know where we'll end up next. Tonight, we're going to play back the timeline on the agent boom. What happened when AI agents' ability to develop software went parabolic? And I'll share my experience using these agents. We'll dive into how to build with agents, focusing on the landscape of new tools at your disposal and the best practices to get the most out of engineering with them. And then we'll finish by looking into the future of software engineering. Uh, will we still have jobs? I don't know. Stay tuned to find out. First, a little bit about me. I'm a self described tech surfer. I love using the latest tech to build awesome new experiences. It all started back in 2002 when I first learned about Google and HTML and built my middle school's webpage. Then in high school, I leveled up and used robotics to build a submersible remotely operated vehicle with a buddy that was eventually used by our local crime scene investigation unit to find a gun in a river. That was pretty cool. Fast forward to college, Hookem, where I started a big data machine learning company that composited MRIs into 3D images and used machine learning to identify candidates for stroke medication. Then about 4 years later, I became super interested with the iPhone and the release of the App Store. I built a bunch of apps, some of them kind of weird. You should ask me about them later. Next, I started a spatial computing company where I somehow ended up studying cadavers to invent a surgery simulator. I started a weekly VR conference that took place in VR, where we even had a t shirt cannon where if you caught a shirt in VR, you'd get it in real life. That was cool. Uh, then I became interested in permissionless composable software and started writing smart contracts on the blockchain before finally starting down this AI rabbit hole about 3 years ago, where I built a group chat agent that worked in iMessage to help people get used to interacting with AI, and a data stewardship platform that uses natural language to understand how products are sold and processing point of sale documents to essentially let companies understand their data. All that's to say, I've been around software engineering for a while, and I'm familiar with a lot of different stacks in the ecosystem. But none of that matters anymore. That was all in the before times when software was made by human hands, just like our forefathers did. And the reason everything is different can be summed up in a single word, and that's agents. You probably would have guessed this. If you don't know what an agent is, here's a quick little primer. First, you need to understand what an LLM is. It's basically a model that generates the most likely continuation of text. So if you had an LLM and you asked it, pick a good dinner spot for 6 in Austin next Friday, it would give you something like this. Sure, how about craft omakase? That sounds great. I would love to go to Craft Omakase, but it's not really possible to get a spot for 6 in such short notice. And that's why this is actually a pretty bad answer. An agent can help mitigate this. The way it does it is it puts an LLM in a decision and feedback loop. It sets a goal, it chooses a next step, it can take actions on a set of tools, it observes the results and repeats, using all this new information as context until the task is completed and an output is produced. So let's ask this agent the same question. Hey, what's a good dinner spot for Austin for 6 next Friday? The agent will set its goal. I'm going to find an available restaurant for 6 people. Then it sees the context that it has available. It sees it has 2 tools. We gave it Yelp and OpenTable. And it'll ask Yelp, hey, give me the best restaurants in Austin. Yelp will reply to the LLM top 10 restaurants. Now it knows, okay, I've got top 10 restaurants. Are any of these available? I don't know yet, but look, I have another tool. Maybe it'll help me figure that out. It'll ask OpenTable, what are the available restaurants from that set of 10? OpenTable gives 3, and then it can produce an answer. How about Kanjay? So that's the gist of it. Now that we understand the basics of what an agent does, let's talk about the agent boom. This, like I said, was a huge year for agents, especially how they interact with software. And to understand why, we should go back in time to November, this past November. Ever since large language models could spit out code, there have been tests with the set with the mission to evaluate how good they are at completing that code. SWE Bench or Software Engineering Bench is a respected benchmark that pits LLMs against a set of varied coding problems. Uh, and basically the score determines how many of those problems the model got correct. GPT 4.0, which was essentially state of the art in November, had a score of about 31%. Then OpenAI released their O1 model publicly, and this jumped up to 48%. It was the first model released with reasoning built in. This meant you could give it a prompt and it wouldn't just spit back a response like your standard LLM. It would actually do some sort of thinking around it before creating a final reply. This new thinking paradigm is ideal for building agents. It's slower, but the number makes it clear that reasoning models were going to be big. Fast forward a couple months, and you get this: Claude 3.7's released. It's efficient, it's reliable, and we just doubled the software engineering capabilities of agents in 3 months. So the world was kind of freaking out at this point in terms of the agentic coding world. At the same time, Anthropic released Claude Code. Claude Code lets you run Claude models directly via your terminal inside any directory of your choice. This is a deceptively simple design, but it's really beautiful because you can now just put an agent into the context you want anywhere on your computer. It's really great for building software, but people can use it for all sorts of things like building marketing workflows. The term vibe coding was said for the first time by Andre Kaparthi, and software engineers everywhere started panicking because all of a sudden CEOs that programmed in the 90s were producing some pretty good looking apps. Tools like Bolt, Replit, and Lovable have their moment and gain millions of users. Regular folks get this spark and start vibe coding. But then those users start shipping those apps onto the internet, and the internet kind of hugs them back in a really nasty way. It turns out they were wrought with infrastructure issues, security problems, all sorts of things that the agents weren't really catching or implementing correctly. Then there was a collective sigh of relief by software engineers because it turns out this whole vibe coded beauty was just skin deep. Or was it? I don't know. From December to August, in the span of just 8 months, the software engineering agent was born. Its capabilities more than doubled. These numbers only tell half the story because we're just describing the capabilities of the underlying model. There's still this whole cultural shift that needs to happen with the rest of the community actually using these models and learning the best way to apply them and what sort of tools they need to use them best. I was fortunate enough that I got to dive headfirst into what was happening. I call this my vibe era. I spent 10 weeks from February to May just building whatever I could think of. I just heard of Replit and shortly thereafter Claude Code and decided to take them for a spin. Just a little bit. What's the worst that could happen? I started building an AI marketing researcher where you could input a business idea or your business website, and it would analyze it, do some deep research, and try to find your first customer. So I was like, why not build AI with AI? So that took a week and a half, which blew me away. Next, I thought, how about we build some real infrastructure? So I built a scraper service on Railway that scraped all of Reddit's posts that were on slash r all, and that took about 1 week. I couldn't sleep. I needed more. Okay, now I'm building with agents. Why not a service to let people make their own agents? That took another week. I had coffee with the founder one morning. He was explaining how he had all this inbound and needed a way to determine which leads were valuable. Do I smell a market opportunity? Boom, 2 days. Was I addicted or was I Oprah? All in all, I built about a dozen services and apps over 10 weeks, culminating in eventually a social network that I built just for agents. This was the bottom of the barrel type stuff. I was going crazy, I think. And the agents were just talking to each other, posting. As soon as they started trying to name the app, I knew I'd gone too far. So I took this moment to step back and reflect on my experience. What did I gain other than a large infrastructure bill and a dozen marketing problems? First off, if you build software, congratulations, you now have superpowers. This was the crux of what made this all so addicting. The power behind it, I'd been building products for over a dozen years, and that means I had the tool set to understand exactly what to ask for, which APIs to connect to, where I could get data from, how I could make different pieces of functionality work, how I should structure my API, what sort of security features I need to build in. And that made interacting with the agents a breeze because I could ask for very specific things and that would get built out in minutes instead of hours. Models are the new programming language. When every model is trained on every public language, you don't need to know specific syntax to have success. Each of the major models, GPT, Claude, Gemini, they behave in different ways. They each have their own quirks and their strengths and weaknesses. Gemini, for example, was the first one to have a super large context window. That means you could uh, give it architectural issues that feed in your entire code base, and it could reason across all of it. Claude Sonnet was really good at behaving almost like a fine scalpel where you can direct it to a specific bug or feature you wanted to implement, and it would do it better. Uh, that being said, things are shifting really quickly. GPT-5 came out just a couple weeks ago, and it's already becoming more and more of a daily driver for me. So all I can recommend is developers familiarize themselves with the major models and get a feel for when to use which one. You have to work like an engineering director. When you're an engineering director, you're not focused on the day in, day out of the actual specifics of the code that's being produced. You're worried about the team that you're managing. You're trying to figure out the right way for them to support each other. Are there test suites in place to identify any regressions when a new feature is produced? Do we have the right safeguards in place to make sure someone can't just ship an untested bug out to production? Those are the types of questions you need to concern yourself when you're working with agents to build software. How do you set up that same infrastructure for your agents to set them up for success? Things are moving fast. I don't know if any of you have been on Twitter, but trying to keep up with the latest trends and announcements in this space is pretty much a full time job. You get bombarded with new methodologies, new releases that are getting discovered. It takes a lot of work to identify which one of those pieces is actually helpful and which ones are just trash. Lastly, the future's here. It's just not evenly distributed. Great or getting great results from these models is possible, but like any tool, there's a big learning curve to it. These models are extremely capable today. That 75% figure is nothing to gawk at. It means they're capable of doing over half the work. And now our job becomes figuring out how to best focus them, put in the correct guardrails and the correct way to evaluate the work they produce to get the most out of that 75%. So how do we actually do that? Where do you start building agents, and how do you get started on this path? So let's take a tour of the agentic coding landscape. We're going to go over these four categories: IDEs, MCPs, which is model context protocol, orchestration tools, and cloud agents. First, let's look at IDEs. This is where your code and agents meet. Your code gets to act as context for the agents, which is super helpful, and then your agent gets to interact with the code. Looking at the big three, we have GitHub Copilot, Cursor, and Windsurf. These all feel like traditional IDEs because they're based off of one, VS Code. GitHub Copilot is a VS Code extension, and the other two are just branched off of VS Code. Here's one of them in action, Windsurf. On the left, you can see the type of head functionality that's been around for well over a year. This basically runs a light LLM across your code, like the file that you're on and files you visited. And wherever your cursor is, it predicts what the most logical thing to insert there might be. The real magic happens on the right, though. This is the agent panel. This is where you can direct your agent to implement a feature or debug something. You can also maybe research how a workflow in your code operates or ask it to write documentation. And I think we should do that right now. So I'm going to open up one of my projects in Cursor and write some documentation with it. So I have my project here. Just a little bit of context. I'm going to let you know it basically conducts a submission pipeline for processing spreadsheets. Uh, as the spreadsheet is submitted, it goes through several steps, normalizing the data, going through transforms. It gets enriched with AI, obviously. And then I'm curious, can the agent document this for me? This would be really valuable artifact to have because once I have the documentation, I can then reference it to another agent so that it has a primer on how this whole pipeline works instead of it having to research everything itself. So here I have the agent panel spun up. I've picked a model. I'll pick Claude 4 Sonnet 1M, which was released just a few weeks ago. And I'll ask it, will you analyze and document my submission pipeline starting in normalize, write it in a markdown file in docs. So you'll see the agent, well, yeah, here we go. So the agent starts going, it generates its goal, starts creates a to-do list and starts going through the whole process. It's going to read a whole bunch of files. It is probably going to take a few minutes. So I already did this before coming up here, and I'll show that to you. This kind of feels like those cooking shows where they put the uncooked turkey, and then we get a fully cooked turkey out of it. Uh, the basically what it produced is a document. The top is an overview. It goes over the core concepts, shows where in the code things happen, actually outlines my pipeline, the flow. And like I said, this is just a really valuable thing to have because in the future, if I ever want to do some additional work with this pipeline, I can just reference this document directly instead of going to it and saying like, hey, let's analyze my pipeline and then work from there. And it's also a good thing to keep up to date. So let's switch back. We'll come back there in a little bit. All right, continuing. Next, we have the newer CLI tools, such as Claude Code and OpenAI's Codex. They took this concept of a command line interface, which has been around since early computers, and they gave it a facelift. They literally just got an agent and put in the command line interface. And like I said before, it's a deceptively simple idea, but it's really great because now you can use these agents anywhere on in any directory on your computer. It doesn't just have to be code. Super easy to install. If you use ChatGPT or Claude, you get free usage on both of them. So just install that on your computer and you can take off. Additionally, they have the added benefit that because you can use them anywhere, in the traditional IDEs like Cursor or Windsurf, you can open up a terminal window in there as well and just start using Claude or Codex or both with the agent panel, which is kind of fun. Model Context Protocol. This is an open protocol that plugs into agents. It gives them new context and tools. And there's a bunch of them. People and organizations have been cranking out MCPs to give new tools and context to agents. Many of them are focused on giving your agents new information. So, as some of you may know, models are updated, months in the past, so they don't know what the current use is or anything like that. You can give your agent current news by plugging in Perplexity MCP into your agent. Maybe you're building something that requires location information, you can plug in Google Maps. Maybe you want to give your agent organizational information, so you can plug in Notion to get some docs of what your product is, maybe from a more human level. Google Drive to see slides and presentations and sheets that your organization keeps. Slack, maybe you have a thread on a new feature that you're working on and you want your agent to be able to read that to get the right context. Then there are MCPs that not only bring in context, but also give your agent new actions uh, that it can take. It lets them actually affect the world outside of your code. Maybe you want your agent to help you set up your infrastructure on AWS or Google Cloud. There's an MCP for that. Maybe you want it to run a migration on your SQL database. Kind of risky, but there's an MCP for that. Maybe you wanted to update a ticket on Asana or update an Epic. Asana has an MCP. Perhaps you're working on an e-commerce website and you want your agent to create a new product for you as you're working in the app in the code. You can do that with the Stripe MCP. One MCP I want to call out in particular because it's super helpful for software engineering is Context 7. This one's a must. Basically, what it does is it has a giant library of the most recent documentation across all sorts of libraries like Next.js, the AI SDK, Tailwind CSS, infrastructure docs from Google, AWS, and it lets your agent access that straight away. So if you're ever building something, you can reference context 7 to your agent, say something like, am I using best practices in my pipeline? And it could go through, see what sort of frameworks you're using, reference context 7, and it will know and be able to definitively answer where you are or are not. Um, Another thing that people mention a lot with MCP is sort of drawing the parallel between that and an API. I want to touch on that quickly. They're basically, you hear the question a lot, isn't an MCP just an API? The short answer is yes, an MCP is just a wrapper on an API. However, the big difference is the discoverability aspect to it. When you plug in an MCP into an agent, whenever your agent first runs, it pulls in the context of what's available on the MCP. So it can learn new functionalities just by the MCP being updated. This does introduce a big security risk where if you're using an MCP from an untrusted source and it had a certain set of features that you were familiar with, those could get updated and introduce some sort of dangerous things into your workflow. So that's something to keep an eye on. The third category of tools is agent orchestration. These are a new set of tools designed around running and managing multiple agents simultaneously. Here's a video of one in particular called Warp. You'll see here it sort of ties in some of the concepts we already talked about, such as using an MCP on the left-hand side. And then they tabbed over and they created another agent. And now they're asking it to do something else. And now both agents are running at the same time. If you're not careful, this can be a little bit wacky because all of a sudden the agents can try to like cross-contaminate each other, and that's a little not risky but just not going to lead to good results. That is though why I like this tool here. It's called Conductor, uh, and this uses a really neat git feature called work trees, and this allows you to kick off multiple agents, and each agent uses a sandbox environment to actually work on the code. So you don't have to worry about the agents bumping into each other. They can go spin off, and then you can review those individual work trees and decide what you want to bring in or keep out. And speaking of sandboxes, you can run agents in the cloud too. This means you can run agents from anywhere and find them across all sorts of different clients. Using a tool like Gemini Code Assist, which I recommend everyone turn on. It's a GitHub app. You set it to your repo. Whenever you open a PR, a pull request, Gemini Code Assist will go through, read the diff in your code, and identify if you have any sort of architectural issues or bugs, and it'll offer up any suggestions that you might need. And so this is like a very like low impact, cheap way to just get extra eyes on code. ChatGPT has Codex, which runs in the ChatGPT app, which is really great because you just have to hook this up to any repo that you're using, and all of a sudden you can kick off a new task while shopping at HEB. Okay, so you have all these tools now. How do you actually use them? I came up with three fundamental best practices to leverage these tools and agents. And there's one big disclaimer here. I developed these practices from working, observing, and talking with others over the past 6 months. It's only been 6 months. The floor is shifting really quickly below us. It could be the case a couple weeks from now that there's like some new release and all these practices are irrelevant. So I recommend that you keep a finger on the pulse and as if you're working with these tools. So the best practices, context is key. You need to prompt precisely, and you need to let agents check their work. Agents uh, spin up just with their world knowledge. They basically have amnesia. They're blind to your project or feature that you're trying to build, and so you need to have the right context in the right place to give them a good way to get up to speed on the things you care about. If you've seen the movie 50 First Dates, this should make perfect sense. You want to keep an agent's markdown file. It's a file with rules and important information for your agent to reference. This is just a very simple one. It tells the agent where to run tests, how to run them, how to install things. The reason this is really important is because you might casually ask your agent to run a test when you have a test suite. And if it doesn't know, for example, that you run tests by PnPm tests, it might try a different command that might be commonly used in other projects. And it could all of a sudden think that you don't actually have a test suite and it might just go start writing tests. And all of a sudden your agent's writing tests instead of running the test suite you already have. A lot of agents already support this out of the box, meaning you don't even have to point them to that markdown file. You just write one in your project, and these popular agents will just pick it up and use it as rules. Codex supports it, Jules, Cursor, Factory. It's pretty much everywhere. You need to keep your projects organized and documented. This is pretty straightforward, but a well organized code repo is easier for humans and agents to understand. Fortunately, agents are actually really good at restructuring projects and cleaning things up. So if you're in a bad spot, you can just start using an agent to clean things up. You want your feature specs to live alongside your code, and you want to keep them as up to date as possible. Think of them as a ground truth for the different parts of your project. This is really handy. You can use them to coordinate with other humans, even the ones that don't know code. You can point to a living document that says, this is what feature we need to implement, this is how it should work, et cetera, et cetera. B, because you can use this exact same document with an agent and point it to it. So I really like keeping the documentation sort of into a single form that I can share with other people and with agents. The next best practice is prompt engineering. It's where software engineers still have a big edge because they know exactly what to ask for. This is where you get to express your deep knowledge in software by asking the model to do precisely what you want. When introducing a software engineer to agent-based development, the key is to reframe how you think about prompts. Instead of just saying, do this thing or that task, you want to structure your prompt and in as specific as possible. Think of it as like handing off a task to a junior developer to go and implement. That's how detailed you need to be to implement, to define it. And then that's going to lead to the best success. Anything you leave undefined or unspecified is room for the agent to improvise and make its own decision, or even worse, not implementing something like a security feature. Using an agent to generate specs before ever touching code is my preferred way to do this. And so I want to show a demo of that. So I took this document here and I decided that I wanted to actually change the infrastructure I use on this pipeline from Temporal, which is a service, to Google Cloud workflows. And so I fed this document that I generated earlier to a agent and asked it to generate let me see if I can find it, this workflow migration document. Basically asking it, I'm currently using Temporal. I want to switch over to Google Cloud Workflow. Here is a description of my documentation. Can you outline how we actually do the migration? And it spat this out, which, is great. I could go in here and read everything it says. I'm sure it's got a lot of errors in there. But what I really want to show off is how once you can start building out a spec, you can then use other agents in conjunction all at the same time to review it on your behalf. So let me close this really quick. Down here, I've kicked off 3 different versions of Claude, and I asked it to analyze this exact same document from different perspectives. So I asked one to analyze it for infrastructure best practices. I did a call out to context 7. So it actually goes in, reads, uses context 7, and produces a best practices document. I asked another one to create a threat model on the migration. I asked another one to evaluate whether the test suite that was outlined in that document, if that was any good. And those agents produced 4 different documents here, all of them with different recommendations. And this is where things get a little bit more interesting because you can actually start seeing the gaps in the initial migration plan that was created by the first agent, and you start getting an idea of where things need to go from there. The next best step for me to do, or for you to do then, is actually merge and redline those reviews. So we'll just kick this off right now. We ask it to take those different reviews, we point to where they are, we point to the workflow migration, and then it's going to take off and actually start analyzing those different documents and how it relates to the original and then merge it into one. So this sort of extraction and then collapse is a really handy way to sort of iterate on these specs before you ever actually prompt the agent to go and even change any pieces of code. I wouldn't feel comfortable doing this migration with an agent until I was really comfortable with the spec. So I would go through this process back and forth, several agents, single agent, until I got to a really good place. And then I could actually go and do the migration with an agent. And finally, it's crucial to let your agents check their work. Make them write tests before writing code, and you evaluate those tests. Have them check their work against the tests. Make sure those tests pass before the work is done, and give them the tools to observe the work outside of just command line interfaces. Things like Puppeteer and other tools give observability to the agent where it can actually look at an interface that it built and be able to iterate on it. It'll build something, it can check what it did, it can observe what may have broken or doesn't work, and then iterate and continue until the task is complete. Now, if you're a software engineer and you're not using any of these tools or best practices, I think you should. I think you'll find they're extremely helpful. You shouldn't be threatened by the tools. I think software engineers are best suited to leverage these tools. However, we are just another boom away from the models taking another big capability step and moving things forward in a very unpredictable way, changing the way we work again. So I think we should think about what this change might look like and how it will affect software engineering. And a good way to look at this is through the lens of code versus communication and seeing how that relationship will evolve. So can I get a quick show of hands? Who here has used JetBrains or Xcode or Eclipse? That's quite a lot of you. How about VS Code? Yeah, more. All right. Replit, Bolt, or Lovable? Not as many. How about ChatGPT or Claude? Yeah, it's pretty much everyone. Thanks. You can put your hands down. All of you can and will generate code. And you'll be using these amazing models that generate really high quality code. But does that make you a software engineer? How do we avoid ending up like this guy? What's the bottleneck to great programming? So Sean Grove is an alignment researcher from OpenAI, and he says that the value of software engineering or the value of a software engineer is not equal to their code. I like that statement. He says that their value is in structured communication. He talked about this and it really resonated with me. So I just wanted to share a few key points from that. What do you do as a software engineer? You talk with users to understand their challenges. You distill these discussions to ideate concrete goals to alleviate those challenges. You plan ways to build these goals. You share those plans with colleagues. Then and only then do you actually translate those plans into code. Then you test and verify not the code itself. No one outside the software engineering team cares about the code itself. What you care about is when the code ran, did it achieve the goals? Did it alleviate the challenges faced by your users? These are the skills needed to be a great software engineer. Structured communication is the bottleneck between humans and great programming. Knowing what to build, talking to the people and getting requirements, knowing how to build it, knowing why to build it, and at the end of the day, knowing if it has been built correctly and has actually achieved the intentions that you set out with. The more advanced the AI models get, the more we will feel this bottleneck. Because in the near future, the person that communicates best will be the best programmer. It will literally become that if you can communicate correctly, you can program. And we have this sort of source of truth shift happening in software right now. Yesterday, code is the source. Literally, the code is the source of truth for the program. You would run the code through a compiler. You can target different architectures, x86, ARM, and you get different build artifacts. No one really cares about the build artifact, but at the end of the day, that's what's running on different people's devices. Today, prompts are scaffolding. When you vibe code, you write up a prompt, you send it off to an agent, the agent produces some code, and then you throw away that prompt. That's kind of weird. At least I think so. After all, the prompt was the human input that created the code. We're quickly approaching a world where prompts become the source of truth and interacting with code becomes a problem just for elite software engineers working on frontier coding issues. This series by Angel Rogado on Twitter perfectly illustrates this. He takes the exact same prompt structure and passes it through different lenses of different models. Uh, in this case, he described a particle simulator where he could drop in different types of substances into the scene and have them interact with each other, respecting some types of physics. Over here, these are early tests with GPT-3.5 Turbo. That feels like forever ago. GPT-4. Then more recently, Grok Code Assist. You can see it's already looking a lot better. And just a few weeks ago, here's the one that came out of GPT-5 Thinking. Honestly, it's pretty remarkable. And this all came from the exact same prompt. Even the UI affordances that were designed in and put in the right place, you can literally see how his prompt is coming more and more into focus into an actual end artifact, end result. As agents become better interpreters of structured communication, we'll stop leaking intent and prompts become the durable source of truth. While I think the shift will put less pressure on people to develop unique, deep technical skills, which is kind of the end of an era, it will apply a lot of pressure for us to develop a skill that I think is extremely valuable, universal, and lets us understand each other better. So to recap, we're leaving the Vibe era behind. In under a year, model capability jumped dramatically. Now the constraint is how precisely we communicate goals, guardrails, and checks with agents. The orgs that treat specs as the source of truth, I think, will outrun those that treat code as the only source of truth. And models are the new languages. communication is the new performance path. You need to make specs the source and let code be the receipt. So thank you.
Thank you, Tony. All right, so we have plenty of time for questions. And I learned of Tony through one of our board members, William Hurley or Worley from Strangeworks. And so I've asked Worley to moderate the Q&A today. So he's already, within 15 minutes, he said, man, there are so many great questions in here. So we've got lots of time for Q&A. So we're going to have Worley pick his favorite questions that have been submitted in Slack and talk to his good buddy, Tony.
I just wanted to do it to make Tony extra nervous since I pretty much threw this on him. Man, there's a lot of good questions, Tony.
Oh, sorry, Tony.
Yeah. Well, do we need one for the audience? I mean, I'm just reading them, right? Yeah, perfect. All right. So
Cool.
there are a lot. So we'll try to rocket through them. We have some time, but we'll try to get through the majority of them. The first one is, my question is, if AI does the code writing, who does the regression testing? Now, you kind of talked about setting up the tests first, but
Yeah.
hit that one up.
Well, I mean, I think, like I said, you definitely need to set up a test framework early on and maintain that as you go. You shouldn't ever let an AI loose in your code base without first writing tests. And if it's something that you can't test, then you just need to go in really small steps, because otherwise you're going to get into a situation where you release something that could be problematic or dangerous.
So as development cycles accelerate with AI assistance, could our pursuit of rapid iteration be building technical debt faster than we can recognize it? And what does this mean for the longevity of the systems we're creating today?
Yeah, that's a good question. There's definitely a situation where you build up technical debt. I think today you're going to be bumping into that a lot more than we will soon as we build out these practices. What I was alluding to with the whole specs concept is this idea of being able to define your project in these documents and essentially rebuild your project on the fly, later down the road. Obviously, we're not there yet. Technically, you could do that with smaller projects. But yeah, if you just start ripping and prompting and vibe coding, you're going to have a lot of technical debt.
Yeah. How is the rise of AI and automation changing the economics of software development and deployment?
Yeah. It's definitely making it cheaper. I mean, price per line of code is going way down. I know that. I think I'm still not convinced that someone that doesn't know software engineering can develop software projects today. I wouldn't make that claim. I do think that might happen at some point. And in that situation, you're going to have a sort of reckoning. The problem is that you have the ability to generate so much more code. I do think, I don't know what the exact figure is, but a software engineer that's enabled with these tools is maybe not 2x as fast as a standard one, but I think it is a double-digit percentage increase in productivity.
So in this agent-driven future, who will be held responsible for ethical dilemmas or harm caused by autonomous decision-making? Human users, agent developers, or agents themselves?
Humans. I don't know. I mean, so I mean, you have
We haven't got to the hard ones yet.
Oh, okay.
I'm just kidding.
You get into the typical scenario of, like, if a Waymo crashes into someone, whose fault is that? I mean, ultimately, I think organizations are going to should take the blunt of the responsibility, because it's a group of individuals putting out this product out into the world, and they should be responsible. Yeah.
So are you finding it more useful to continually mature existing agents or to rebuild those agents every time? And do you consider agents to be mobile as you move from like LLM to LLM?
Yeah, well, so I didn't really touch much on actually building out an agent. If you wanted to do that, I think rebuilding agents is probably it's something you should do if you started building an agent out 6 months ago, because things have changed a lot. The Vercel AI SDK is really flexible and composable if you are building an agent. And using a tool like Open Router makes it super easy to essentially plug in whatever LLM you want to into that agent. So I would say if you're using Vercel AI and an Open Router, you're probably in a good spot. But if you built your agent on like LangChain, for example, you probably have a lot of technical debt around that agent, and you have some optimizations to make.
So how are you calculating the software engineer capability percentages you've been showing? Like, how do you compare agentic LLM capabilities to what you expect from like a junior, senior, mid-level developer?
Yeah. So, I mean, the way I would look at that figure is given any software engineering problem, is the agent capable of solving the problem if it is described correctly and it has the right context to attempt it? So, I think yeah, it's probably an advanced software engineer. I wouldn't be like I think the agent's probably, you know, I better than most software engineers in terms of being able even, non-juniors.
So, well, MCPs, is this kind of like the next generation of APIs, how we all kind of started using those?
Yeah, I mean, there's still a lot to there's a lot of politics around it. If, in case you don't know, MCPs were started by Anthropic as an open protocol. OpenAI then backed it, so everyone for a little while was really excited that maybe these are sustainable and will be used going forward. But OpenAI still has a lot of sway, and it's reasonable to think that they're trying to essentially own an app store. So it's tricky to see where they will go. But as far as being an AI API replacement, for now, yeah, it's the best way to bring in that sort of capability into your agent.
All right. So, what would you tell a middle-aged programmer now unemployed about how to start? Don't everybody laugh. It's gonna, according to him, that's gonna be like most of us. Like I'm gonna be in that category. What would you tell a middle-aged programmer now unemployed how to start upgrading their skill set to learn to use these AI tools you've shown and increase their chances of eventually getting hired for those skills they developed to work with AI programming tools?
Yeah, well, I think pretty much all the major, your Metas, your Googles, Microsoft, they're all going to want people that know these skills. I don't know when it becomes strictly necessary for new hires to know this stuff, but I think the easiest way to get started is just download Claude Code, open it up in a project, and just ask it to tell you about the project. And then it'll kind of start unraveling or opening the window for you to see how you can interact with it and what you should ask
So
next.
just kind of experimenting, just like
Just
you would have done with software when there was
just
no agent.
just use it. Yeah.
Right.
Like
Go download some open source, screw
yeah.
around with it.
How do you build an
see what
HTML
breaks.
website for your middle school? That's
Yeah.
one bracket at a time.
All right. So do any of these IDEs let you run multiple LLMs at the same time?
Yes, Cursor has sub agents, and they even have cloud agents you can dispatch directly from Cursor. So, and I'm pretty sure GitHub Copilot does as well. So you could literally, instead of running the agent on the code in your IDE, you could dispatch it to GitHub, and it will run it in the cloud in a sandbox. It's pretty expensive, but it is possible.
And when you're making that code, how maintainable is the code currently being generated by these tools? From a human point of view, does it make sense? Could you see its flaws and extend it? Do you see this getting to the point where that's moot and it will only be maintained with the aid of an AI?
You got to test everything. I mean, if you're covering a lot of ground with agents and they're spitting out a lot of code, you need to be able to test the code they produce, because if not, you're not going to catch anything. So, like I said, you got to define those specs. You have to build out test suites that you can run, and you have to be convinced that those test suites are covering, as much of your code as possible. And then every time your agents run the tests. Did anything break? Keep going.
And I know I'm moving fast through this, but just so you know, I've asked all those questions. There's still 42 unread questions on here. So I'm trying to get to everybody I can. How do we design agent interactions that preserve the developer's flow state? When the traditional rapid feedback loop of coding gets replaced by longer AI processing times, What strategies could you implement to keep users productively engaged during those write and wait moments rather than leaving them feeling disconnected from the work?
Oh, I see. Yeah. Well, I mean, for starters, agents definitely code much faster than humans. So I think that flow state of like, I guess going through and building things out, that's a type of flow state for sure. Maybe the answer is sub agents. Try to manage how, like, think of if you had a team, how would you check in on those different members of the team and try to manage your team as efficiently as possible? And sub agents or, parallel agents is the way to do that. And that takes a lot of effort.
So, if companies are de incentivized to employ junior engineers in the current age, should we be telling the recent grads and recently unemployed to strive for roles in like, sure. If companies are disincentivized to employ junior engineers in the current age, should we be telling recent grads and recently unemployed to strive for roles in like product owner, product management, or other opportunities?
Um, I, it's a tricky question because I am like I suggested at the end there. I do think the role of like a product manager or a product owner and a software engineer, at least mid to low level software engineers, that career path is going to converge because there's no reason why a product manager who goes and talks to users, talks to stakeholders, defines a product, defines the different features of a product. There's no reason why they can't actually get that built out by an agent. So if you're interested in that skill set, if you're interested in product, I think that's a great like career path to go into. It's a lot of fun and it is mostly about communicating. So it's just figuring out how to get the right thing to the agents.
So, QA tools, besides unit testing, are there tools that can automate testing UI? Claude computer use and Perplexity comment don't really appear to be that reliable. Are there any other things you could suggest?
Yeah, Puppeteer. So I'm not sure who asked that question, but Puppeteer works to build out different UI tests. Playwright can be built out to use the to write the UI unit tests, and Puppeteer you can actually run your project live or have your agent run it live. That's more of like a computer use situation.
Got a lot of questions here. Here's a good one for you. In the capitalist rush for AI driven efficiency, how do we ensure non tech management uses these new tools to empower developers and product managers, not just to try to eliminate their jobs? Um, what do you think about that? Like, we've seen that argument, right, in the press recently where it's like, everybody let people go at this company and now they're missing the people. And we've seen it from both sides. What are your thoughts?
Well, I mean, I think a lot of those jobs, it was a matter of an efficiency situation where you had these middle managers that you don't really need in place once you essentially need less friction between like product owners and software engineers today than you did before because of these AI tools and the fact that you can bring in all this context gives people a lot of power to essentially I guess build out their ideas in a more thought out way. And now you have things like deep research where you can actually go and conduct all this research across thousands of websites and get a report printed out in like 20 minutes that would take you hours and hours and hours. And so all that's to say that these efficiency shuffles that are happening, I do think it's because there is a need for a new type of work and things are just being restructured. I think there will be jobs for everyone.
Okay. So many questions. I think we're almost to the end. Um, but I like this one a lot because you talked about communication and you kind of implied that software developers for some reason aren't great at communicating or social skills, but that's okay.
The good ones are.
So you mentioned communication will be the most important programming skill. What specific habits or practices should developers start building now to better themselves in that area and kind of prepare for the future?
I mean, I think building out the product specs is a huge thing. Building it and sharing it with other people and asking them if it makes sense is like a great litmus test because if it makes sense to someone that may not be a software developer, then that means you're clearly articulating what the product needs to do. And then obviously you still need technical details in there for specifics that on like defining maybe a type of API or something like that that you want the agent to use. Uh, but getting the idea laid out in a story that makes sense to people is key. And so just share your ideas, I guess.
So another good one about kind of the economics of it. Now that AI has made writing software almost as cheap as writing a document, are we witnessing the death of traditional software development life cycles? Instead of a spec to deployment taking weeks, we can now generate features on demand. Does this mean we're moving towards a world of hyper-personalized, dynamically generated software where every user gets their own custom version of an application, which I know is something we've discussed in kind of one of our favorite topics?
Yeah. I mean, that one's tricky because we're not there yet. Agents cannot generate UIs reliably in such a way that a product or service can use it in production. At least not if it's unless it's like super constrained. But yeah, it's an interesting question of like if you define a product spec as a system prompt for an agent of this is how it needs to behave, you could use that to build out an app, or you could just use that to feed it to an agent, and that just works as the agent is just the interface for your customers instead of some web UI. I think it probably goes both ways.
So we spent a lot of time and money educating young people in STEM because there was a projected shortage of 18,000 software engineers in Austin over the next decade. What should we be teaching them now to prepare them for the future?
So
I absolutely, the question I hate the most when I'm doing this, so I had to save that one for you.
thank you.
What should my kids do?
What should your
Well,
kids do?
what my kids should do.
Yeah. I mean, I would say if they're interested in product, teach them product. Like again, just I'm harping on this, but the product spec, identifying, being able to articulate what your product does is going to be the most valuable thing. And so, and a lot of that comes down to, okay, what are the steps to actually use the product? How, maybe how's it, if they're interested in entrepreneurship, marketing is a huge thing. For the longest time, it feels like, technology or technical like co-founders had this huge leg up because they know how to talk to computers, and that gave them a huge advantage in the space. But knowing how to talk to computers is becoming less important. And so you need to be able to talk to humans as well. And so talk to humans and agents, I guess.
So, what infrastructure components do you recommend in a company to support agent development by a wide employee base? Like, if you're a company that
Ye-
hasn't adopted it, like, what would you recommend?
Oh, well, so I mean, if your company hasn't adopted it, obviously I think you need to have, an ambassador inside the company, just someone starts using it and showing off the different tools to their colleagues. But like the step beyond that is once you actually have a company that is fully bought into the idea, you need to start trying to organize the documentation within your organization as well, like making sure your Slack's kept in order. Do you have documentation for your project as a whole, like maybe in a Notion document? Are your Linear or Asana tickets or whatever issue tracking service, is that kept in order? The more organized you can be, the more you can bring that as context into agentic workflows, and the better results you'll get.
So, tell us a little bit about using MCPs for like directly debugging or trying to fix and issues in code.
Yeah, well, I mean, the two I called out for debugging specifically would be, like I said, Puppeteer or
Puppeteer.
Playwright. It's basically just where is your code, but a really good one would be like you could have in a Postgres MCP or an AWS or a Google Cloud Platform MCP, and this means that if you deploy your code and something's happening, maybe on a staging database or production database, the agent itself can go in and read that data. And like a really great thing is they just know how like the AWS CLI works or the GCP CLI. And so you don't even need an MCP for that. You just say, hey, use the AWS CLI to debug this Lambda function, and an agent can go in and find the Lambda function, find the most recent logs, identify what the issue is, debug it, write the fix for it in the code, and then you can ship it off.
So, related to technical debt, who in a company is going to be the one to work to fix the technical debt created by agents? Is that software job? Is that going to be a new person in the testing group? Like, what do you think?
I mean, ultimately, it's right now it's a software engineer's job. I mean, I think sure, could an agent be good enough to go and like fix your repo? Potentially, but not today. And so you need to just tread carefully, take things a little bit at a time, and make sure you're building things right. Because if you're just churning out slop with an agent, you're not going to be in a good place.
All right. So we're on the home stretch, Tony.
Okay.
Recent MIT studies suggest that organizations have seen limited productivity gains from AI so far. How do you explain the gap between the expectations we have on the AI and the agents and the results that are being reported? And what steps would you encourage organizations to take to capture greater benefits from AI deployment?
Yeah, I mean, it's similar question to before, which is just there is this know-how of the model, a capability, what it's capable of, and then know-how of an organization or person to actually leverage those models. I'm not familiar with the study itself, so I don't know how.
Do you think that ties in? You talked in your slides about the like how you were like it's like vibe coding a coin, like everybody went and did it, and now everybody's kind of backing off of it. Is you think
Yeah,
maybe hype plays into that?
yeah. Hype plays into it. People make it seem very effortless. Like obviously, you could have a software engineer go in and they're very seasoned. They can vibe code something that works really well, functions, is secure, safe, and someone else. Maybe they build it out in a few days. Someone else can go in and they get 80% of the way there, but that last 20% is going to be non-functional and broken, and
Right.
that's where the deception.
So we're right at time where we wanted to end, which is perfect.
Perfect.
This is the last question.
Okay.
It's a super easy one.
Yeah.
And you got to keep it fairly short.
Okay.
Because we're all going to go have drinks. But if people are leaving here tonight and they're going out into the world and they're going to talk about this, define the word agent and what it is in a way that they could share that and kind of spread the gospel of this.
Okay. Define the word agent in 2 words, you said? No. An agent is just a computer that can reason over a question. It has tools to try to get to an answer if you were to ask it that. So, well, this is already a bad answer. You should look at my slide on that one. I guess I would put it as an agent is an LLM that can get shit done. That's it.
Okay. All right. All right. Thank you, Tony. Great.